This is a full procedural Rubik's Cube made with geometry nodes. With this tutorial you'll be able to use this asset and play with this fantastic game. So let's get started. I'm working with Blender version 4.1.1 and to make this Rubik's Cube we need to add with Shift A a simple mesh like a plane, go to the plus menu, General and Geometry Nodes, press New to create the new geometry nodes and rename these in Rubik Cube. I suggest you to use only alphabetical characters inside this name. We can activate this snapping tool. So to make this cube we are going to create a cube using its vertices as the point where we are going to instantiate another little cube to get the entire and final cube. So we can imagine each cube can have 20 millimeters for the height, the length and width. So because the length of this side is 20 millimeters, we can see also this distance is 20 millimeters and this distance is 20 millimeters. And these points are the center of each little cube inside the big cube. Okay, so we need to make a little cube with the height of 40 millimeters by 40 millimeters by 40 millimeters. So we can create with F3 a cube 4 millimeter by 4 millimeter by 4 millimeters. We can link these to the geometry input, focus on these, press Shift Z to see the wireframe mode because we need to increase with the 3 vertices for each side to instantiate the little cube on these vertices. So now that we have the structure of our big cube, we can link these to an instance on points node, and here we can link another cube like this and link this with a Shift and Alt pressed to the final group output. But in this case the size of these needs to be 20 millimeters, so 20 millimeters by 20 millimeters by 20 millimeters. Shift Z and voila, we have all the cubes of our Rubik's Cube. Now we can move these a little bit, select these nodes, Ctrl J, F2, global cube, and this is the Ctrl J, F2 single cube. Now the goal is to create a fake effect of a bevel modifier on these little cubes. So to do this we can extrude with this node the faces of our cube and link these to the instance socket, but result is very ugly because we need to offset these by, for example, 1 millimeter, but you can't assign here a unit measure, so you need to think 1 is 1 meter in this case, so 0.001 is 1 millimeter, and in this way you can see the result on these faces. But we have the problem of this sharp effect. We need to smooth this effect, and if you look this from a front orthographic view and press Shift Z, you can see these effect of extrusion, and what we can do is to move these vertices along the normal to be able to move these here in the half position between these two vertices to make a fake effect of smoothness, okay, a bevel with one single segment. And to do this we can use a set position, but we need to select only the original vertices, and one simple way to select only the original vertices of the original cube is to capture the original position of the vertices. So I need to select the vector and I want to save the position vector for each vertex before the extruding operation, and after we can ask if the position, the actual position, is equal to the saved position from this capture attribute. And if this is true, I want to select only these points. So remember that in this point the system will get the position for each original vertex and save this information inside each point. But in this point, this set position will get the new and current position also for the new vertices made by this extrude mesh node. So to isolate these, we can ask if the current position from this set position node is equal to the position of the original vertex of the cube. And you can be sure that it works because the number of the indexes related to this capture attribute and the set position are the same for this purpose, because for this new vertices, we have new indexes made by the system, leaving the original as is. So another example could be take all the indexes with an index greater than 8, because a cube has 8 vertices. So we can move these a little bit, and we need to offset these by what? By the normal of each point, and we need to scale these by a little value and link this to the offset, link this to the instance socket, and we can decrease this value to 0.001, for example, or near 0.0009. Okay, it's pretty good. So now we have shifted these original vertices here. Another method to select these vertices is if the index is less than 8, and if I link these, the result is the same. Why? Because each little cube has 8 original vertices. So the system in this case will leave the same indexes for the original mesh and add new indexes for the extruded faces, so the new vertices. So I can delete these 3 nodes and use this technique, for example. Now I can move these a little bit, move these nodes inside this single cube section, and we have these little cubes. To be more precise, as you can see in the wireframe mode, we have a value greater than 20 millimeters here because we extruded these faces, so we can decrease the size of the original by 1 millimeter, for example, and change the scale of each instance 0.95 to be able to have a little space between all these points, okay, here. And this is very important for the next step. We need to leave a little gap between all these cubes. Now, next step, we need to save the current position of our instances, because next we are going to use this information to be able to rotate the side of the big cube. So for this we can store this information using the vector for each not point but instance, because out from this node we have instances, and we can set here pose and link these to the position, the actual position of the instances. We can select all these, Ctrl J, F2, save, pause cubes, and with the Shift and Alt link these to the group output. Next, we need to assign a material. So to assign a material, the idea is very simple. We can ask if the direction of each face of all these cubes are in a particular direction. So a positive or negative x-axis or y or z-axis, and apply a different material. So first of all, we need to go in the material, properties, add a new material and set the name to Rubik cube. We can put here a roughness of 0.7, for example, no metallic, and we are going to link to the base color the correct attribute we need to save inside this mesh. So to take and ask if each face is pointing along a particular direction, we need to realize these instances, because we need to have not instances but vertices, edges and faces, so the real mesh. So with the Shift, Alt and click, we have now the mesh itself. And first of all, we can save with a store name attribute a color like this for each face, setting the name col. Don't set color here, because in the cycle render engine you could have a problem with no color in the final render. So Eevee works but cycles not. So remember, don't set here the color, but use another name. And we can set a base value of black for all these faces, and if I click here for the preview, we see nothing. Why? Because we need to set the material inside our mesh, and to do this we need to link this to a set material. We can select the Rubik cube and link this to the geometry, and we still have nothing because we saved this black information in an attribute of the geometry called col, and we needed to go in the shading editor, and inside this Rubik's cube material we need to press F3 and add an attribute and select our col attribute and link this to the base color. And now all is black. Go back in the geometry nodes, and now we can duplicate this store name attribute because we need to change the color of the correct faces, assigning a different value of the color. So we can take the normal information of each face and ask if these with a dot product. So what does it mean, the dot product? The dot product means that if you have two vectors like these and an alpha angle here, the dot product is always the result of the absolute value of the vector 1 multiplied by the absolute value of the vector 2 cosine of the alpha. So we already normalized these two vectors because the normal is already normalized, and we need to take an axis from this vector that will be normalized because we are going to set one here, or one here, for example. And this cosine of the alpha will give us a result between -1 and +1. So when we have 1 where the angle of the alpha is equal to 0. So if these two vectors are parallel, if we have two vectors perpendicular, we have 90 degrees, and with 90 degrees the cosine of the alpha is equal to 0. And if we have two vectors parallel but in the opposite direction, we have 180 degrees, and with 180 degrees we have a result of -1. So we have -1 here, 0 here, and 1 here. So in our case we need to assign a different color if the normal of the vector is pointing along a positive or negative axis. First of all the x, then the y, and then the z. So we can start with the x-axis, setting here the positive x-axis. So if this result is equal to 1, this means that the face is pointing along the positive x-axis. And if this is true, we can link this in a switch, changing this geometry to a color. And if this is true, we can set a pure red color and link this to the value. And voila, as you can see, we have the correct color of the positive x-axis faces. Otherwise, we need to duplicate this equal and set if the same dot product is equal to what? To -1. So the result of the cosine of the alpha to -1. So the opposite direction of the normal, okay? So these faces here. And for this reason, we need to duplicate another time the switch. And in a true case, we need to set the orange colors. And this is it. And link this to the false result of the previous switch. Otherwise, we can't have both of these results on the cube. Now we can select all these nodes and press Ctrl-Shift-D and not only Shift-D to maintain the connection between the original normal vector, setting not the one on the x but on the y. Leave these two equals. So in this case we need to calculate the positive y and the negative y. Now we can set a pure blue like this and a pure green. I already saw the correct position of the colors in a normal and standard Rubik's cube. So here we need to link the result of the blue in the false of the previous switch, and the green is already connected in the right place. Finally, we can select all these nodes, Ctrl-Shift-D last time, linking this result in the false of the previous switch, changing the value here not for the y but for the z-axis, using the white color for the top part and the yellow color for the bottom part. And in the false result we can set a pure black. But as you can see here between these cubes, if I decrease a little bit the scale of these cubes, you can see the same result also with these faces, and we don't want to use this. We want to maintain only the external faces colored, leaving the black color for the internal faces. So to do this we need to mask to select the correct faces of the cubes, and to do this I used a simple technique. So I reset the scale of this cube like this, and I decided to create a new cube with 60 millimeters, so the size of the entire cube. And using this I used a geometry proximity, a simple node like this, and with this node I can get the distance between my mesh, so the faces of this mesh, and this cube, this is the bounding box of this, getting the correct distance between each face and the nearest face of this geometry. So to have this we need to increase these vertices to have the correct resolution of the cube used for this purpose. So if I press for a moment the Shift Control and click on this cube and Shift Z, as you can see we have a proxy cube, okay, of the final cube, on which each face can have a distance between itself and the nearest face of this proxy cube. And if this distance is less than, for example, 5 millimeters, a very little number like this, we can select only the faces we want. If I drop this with the Ctrl X and press Shift Z, as you can see now I have the correct black color between these cubes, because all these faces, this face for example, or this face are far away from the nearest face of the proxy cube, okay? But these faces of the cube, the colored faces of the cube, are very near to the faces of the proxy cube. In this way I assigned all the colors for my Rubik's cube, and we can go further. We can select all these nodes, press Ctrl J, F2, assign material and color. Now what we have is the position saved for each face of this cube, and this position is the center position of all of each cube. Why? Because we set this information before the realize instances node. So in this case we can inherit this store name attribute from the instance to all the vertices in edges or faces inside our mesh. Now what we need is to make a step, a rotation step. So to make a rotation step, the idea behind this behavior is to choose a side we want to rotate in a clockwise or anti-clockwise direction using a new input attribute, but the hard part is to choose the correct cubes of the entire cube. We need to take and rotate based by an axis, an X or Y or Z axis. So in this first step we already know the center position of each cube because we set this information here, so we can make a single step. And to do this we are going to add a menu switch, because we need to set the side we want to rotate. So we can go to the node section and set here the front, the back, the left, the right, the top and the bottom side. Each of these choices will give us the result of the rotation step of the side. So we can link these in the front and we can test the front side. We need to isolate only this front side. So if I link these to a set position and link these to the front and start to offset, you can see I'm starting to offset all these faces, and I don't want this. I want to move all the faces that have the centered position of the cube in which they are on the positive x-axis. So if I look at this from the positive y, you can see we have the red faces here. If I press Shift Z, we have to imagine the center of each cube, and this information is already saved for all the points of the mesh. And what we can do is to filter and separate only these points of the mesh to rotate this subpart of the mesh. And to do this we can ask if the stored attribute of the pose separating the x, y and z component has the x greater than what. So as you can see we have position values here in the 0 value, here in the minus 20 millimeters and positive 20 millimeters. Because I need only this part, I need to ask if this value is greater than, for example, 0.01 meter. Okay, remember the unit measure, so 10 millimeters in this case, 0.01. So I'm asking if this position is greater than this line here, this virtual line, 10 millimeters. And if this is true, I can select these. And now if I go in the viewport, delete for a moment my annotation and offset a little bit, you can see the perfect separation of these parts. But I don't want to offset, I want to rotate. So we can offset by what? By a rotation based by the current position of each point and rotate this vector, linking this in the offset, and linking this not in the offset but in the position, because I want to rotate from the original position. So I need to assign a new position. And as you can see, this is the x-axis. I can easily rotate on the x-axis. And as you can see, I'm rotate all these points on the x-axis. So I don't care the center position of each cube, because I need a global axis to rotate all these points. So to rotate in this direction, I can link these to a combined xyz vector, because I need to rotate only on the x-axis. Then I need to link this x to a multiply value, because we don't want to speak in degrees or radians, but we want to have a step. Okay, one step equal to 90 degrees, two step to 90 degrees, so 180 degrees, etc. And also in the negative direction, so -1 is a opposite rotation of 90 degrees. So if I set here one step, okay, value of 1, I need to multiply by radians and not degrees, because I remember you, if you use the original socket of the rotation in these nodes, you can use the degrees domain. Otherwise, if you link something, you need to speak in radians. So one step is equal to 90 degrees, or pi divided by 2. Okay, and as you can see, this is a single step rotation. If I decrease to 0, I have nothing, and if I have 1, I have 90 degrees. And then if you want a clockwise direction, you need to multiply not by pi divided by 2, but minus pi divided by 2. In this way, I can set 1 to rotate in this direction, or -1 to rotate in the opposite direction. We can press H to hide these, H another time here, and H here. I can set the offset to 0, and we have the first step. But here there is the big problem of this tutorial. So from now on, how can I rotate the other cubes? Okay, now we have the first step, but how can I add other sides rotation? So in this moment, I can't duplicate this group of nodes, change the filter, asking if the x value of the attribute pose is greater than 0.01, for example, on the y-axis, so in this part of the space. I can do this in this moment. Why? Because I would filter and mask the wrong little cubes, and this because I previously saved the correct position for each instance and for each point of each little cube in the 0 instant in this moment. But after the rotation, I maintain the same value of the position in the space, but they are wrong after an entire rotation. So in this moment, the correct center position for each little cube has changed, and in detail all the positions of these little cubes here, not for these. So this means that I need to resave the new center position for each rotated little cube before rotate them another time. So to do this, we need to make the first step, store a new attribute, a new Boolean attribute to each point called moved with false set for all the points. Then I will link this to this set position, and then I will store another time with a shift D to duplicate this node the same variable, but filtering only the points I rotated for this step and setting the true value for these points. Why this? Because in this way I can trace the rotated points, because for only these points I want to resave the new attribute position in the space. And to do this, what I need is the original vertices of the global cube, okay, the original 40 millimeters by 40 millimeters by 40 millimeters. So if I press Shift Ctrl and click for a moment, this is the original points where I instantiated the little cubes, and this never changes in time. It always remains the same in the space, and I will use the position of these points to resave this information inside the attribute pose for each filtered and rotated points of the little cubes. Well, to save this information, I can easily drop this viewer, press Shift Z to see the cubes, and after the menu switch, I can take the original global cube vertices, add a reroute point here, and now I can store the attribute of the pose for each point filtered by what? By this attribute moved, because I want to reset the correct attribute pose only for these subcubes, and to do this I can get with F3 the name attribute, setting here the moved points, linking these to the selection. In this way I'm starting to reset the position for all these points and stop. I can link these to the geometry, and now I need to get what? The new center position for each of these little cubes. How? Well, we can use the geometry proximity node, linking what? Linking the original vertices of the original little cube we used to instantiate the little cube, and saving the vector of the nearest vertex of this cube inside our masked and filtered points. So now, to be sure to set this position in the correct moment, we need to be sure to set this new position only if the rotation is completed, not before, because before we need to have this pose information because we are rotating by this value here, and after the entire rotation we need to reset this attribute. So to do this we can add with F3 a switch utility node. We can link the rotation in a value field, and if this value linked to a fraction math operation is equal to 0, so we have the entire step of 90 degrees, okay, in that time we want to reset the position, otherwise we want to maintain the original values inside the mesh. And now I can link these. What does it mean, this group of nodes? It means that we can rotate the side of the cube by float values, but if I have 1 or 2 or 3 or 4 or -1, -2, etc., we have the correct fraction result equal to 0, and in this case, in this particular case, I need to reset the position of the rotated little cubes. Otherwise, while I'm still rotating this side, I could have a problem related to the correct value of the attribute pose inside our points. So in this way, I'm very sure to have the correct new position after the entire rotation. And I can prove you because we have here the moved checked flag on these points. And as you can see, if I decrease a little bit this value, we have the previous value of the pose attribute, as you can see here. And if I set the exact 2 value, I have the new stored position for each point. And now I can duplicate these nodes and repeat the operation for each step. So instead of duplicate all these nodes, I will make a route here. I will select all these nodes and I'm going to press Ctrl G to make a group. In this way I can extend this group of nodes to be able to solve the back, left, right, top and bottom menus, but also to maintain this part of the graph for the end of each step. So I can press Tab to exit for a moment, go here, and instead of have this value that I can drop, we can press N, rename these in set step, press Tab to enter in this group node, link this menu inside the group input, go to the group section, move it a little bit up, rename these in original points, and rename this float value in rotation as a single value, like the menu as a single value. Now we can duplicate this group input to link the rotation here in the point of this fraction mathematical operation, H to collapse, we can move up this switch and these nodes like this. We can move these a little bit and link the original points here in the geometry proximity, dropping this reroute. We can select all these nodes, Ctrl J F2, reset new pose for points of the mesh. Now we can take these nodes. I can duplicate these to link the rotation, because these nodes worth always, and to solve the back, the other sides of the cube, I need to move these a little bit, create a little reroute, take this piece of nodes, Ctrl J, F2, front, and now I can press Ctrl Shift and D to create the part of the graph for the back. So we can select these and set back, and for the back part of the cube, I need to filter always the x-axis, but not greater than, but less than what? Not the positive 0.01 value here, the 10 millimeters, but less than minus 10 millimeters, because I want to rotate all these parts that have the centered position here, here, and here in the space. So we need to set here minus 0.01 using always the same index. And let's check this value. If I link these to the back, I can press tab to exit. I can create a reroute for this original global cube and these, and we can set a little rotation clockwise to see the correct direction of the rotation. And if I set back, as you can see, we have the anti-clockwise rotation by 0.22, and we don't want that. We want the same rotation clockwise, and to do this we need to enter in this part, and here we need to multiply the rotation by the positive degrees. In this way I can flip from the front and the back, getting the correct clockwise direction of the rotation. Now I can take these two group of nodes, move a little bit up, pressing Shift Ctrl and D to duplicate them another time and another time. Now we need to set the left side, and looking from this perspective, so the positive X, Y, and Z, the left part is this part and the right part is this part. So for the left we need to look the Y axis and not the X, so I need to link the Y axis and ask me if I have the value less than minus 0.01, because I need to filter only this part with a value of the pose less than minus 0.01, so this point here. And next I need to rotate not by the x-axis but the y-axis. Okay, I need to rotate using this axis of the rotation. Now let's check the correct clockwise and anti-clockwise value based by this value of multiplication, pressing tab and setting here left. And as you can see, all broke. Why? Because inside these I haven't linked these in the left result. The same for the right, the same for the top, and the same for the bottom. And for the bottom, if I'm not able to link directly these two nodes, I can do two things. One, press Alt and right drag between these two nodes, and the system will link the same type of the first unconnected socket between these two nodes, or Shift and Alt between these two nodes to select the destination of the unique unconnected socket of the from to the to socket, in this case the bottom. Now as you can see, the left is wrong because I have an anti-clockwise rotation with a positive value of the rotation and I don't want that. So I need to go here inside the left part and set the positive value. We can move to the right side. So the right side is this part. I can press tab, change this to the right, press tab to enter, and ask me if the y-axis is greater than what? Positive 0.01. And as you can see, the axis of the rotation is wrong. It's obvious because I don't want to rotate on the x-axis but on the y-axis, so I need to link these. The same problem with the anti-clockwise rotation, so I need to invert the sign of this multiply value to be able to rotate in the right direction. We can move to the top part, press press tab, change this menu to the top, press tab to enter, and now we need to ask if the z-axis is greater than the positive 0.01, because we want the top part, and we need to rotate using the z-axis, and the clockwise is correct in this moment because the rotation is in this direction, so the clockwise direction, so we can leave this value here. And the final bottom part, we can rename it, press tab, change to bottom, press tab. We can ask if the z-axis is less than minus 0.01, it's correct, and we can set here not the x-axis but the z-axis, and as you can see, the correct clockwise rotation by our value. Now that we have this group node, we can duplicate many times, linking the original points for all these duplicated nodes and adding other rotation. So in this case, I can rotate from the front to go to the value of 1. I can duplicate these and connect these to the next node. We can reroute these. We can set a rotation of 0 degrees and change these to left. And as you can see here, in this moment, we have different checked values here for the moved attribute. And now to rotate this part, we have the correct new position for these rotated cubes. So if I start to rotate, I'm using the correct filter and the correct masking of the cubes I need. And I can rotate by 1 step, 2 or 3 or whatever steps you need. Let's break it. So instead of using 1 and 1, I can leave this to 1 and decrease this rotation. And as you can see, out from the fractioned value of the rotation, I have the wrong position for the original part of the little cubes. And as you know, in a real world, you can't rotate at the same time at 2 different sides of a Rubik's cube. You need to end with one rotation to start with another rotation, and the same is here. So remember, if you need to animate this value of the rotation before starting to rotate the next step, the previous step, or whatever step you want, make sure to have all the values to an integer value. And as you can see, if I increase these to 1, I have the correct rotation, and I can duplicate these again like this, pressing Shift D, linking these original points, link this geometry, and link with Shift and Alt this last node. I can select a different side like this, and as you can see, the cube is starting to be very random. And now you can add whatever duplication of these steps and animate your little cubes. You could say, yes, but why not using the split to instances node? Well, because the split to instances node can give you advantages and disadvantages, because the main issue of the split to instances in this case is that when you use it, you lose all the information and the attributes previously stored in the mesh. So I can prove you that if I link these to a split to instances node and press Ctrl Shift and click, you can see now I have one instance, but I don't need to use only one instance. I need to group the points of the original mesh, and because I know that all these subcubes, these little cubes, are connected to the own island, I can link this group ID in the island index field, and in this way the system will take the island's ID for each point and group these points by this island index, making the correct number of the instances. And as you can see, we have again 26 instances, the same number of instances we got here from the initial instance on point node. But the difference is that, as you can see from the spreadsheet, we lost all the information of the attributes. And not only this, we lost the position, the original position, the centered position of each instance. So as you can see from this position column, all the origin point for each instance is in the global origin point of the space, 0, 0, and 0. So the center of this 3D space. And this is wrong. So it's a little bit tricky to understand and reset the initial position of these little cubes, it can be done. I did it, but I prefer to use this technique using the original mesh instead the splitted variation. So from now on, you can easily animate these attributes here. If you want to use this group inside your modifier stack, so instead of adding this group here in these geometry nodes, if you want to add them here in the modifier stack, you can't do it in this moment. Why? Because you have two geometry inputs and you can't use two geometry inputs. So you could, but it doesn't work, and I can prove you, because if I enter inside this group node, I go to the group section and activate this modifier. If I add another modifier here, unassign set step, you can see I have only the menu filter and the rotation, but I have not the original point geometry input. So if you really want to use this set step inside your modifier stack, you need to go in the geometry nodes, the original geometry nodes, and one way is, for example, delete these original points and inside this step group create this clone of global cube to be able to use it in the part of the geometry proximity zone, so to reset the new position for points of the mesh. For this tutorial, I decided to leave this step inside these geometry nodes. In this way, you can use one only node in the stack, and inside you can duplicate as many times you need these nodes. I remember you to make this object as an asset. You can rename it in Rubik's cube, right mouse on this node and mark as asset. Remember to save the file inside the path of the assets of Blender, and importing this asset you will also import the material related to this object. And that's it. So thank you guys for watching this video. I hope you will play with this asset. As always, you can download this project from my download page. Thank you always for your support and see you to the next tutorial. Bye.